Okay, so in this video we will be looking at solving linear quadratic systems by graphing. If you're asked to find the solution to a system, what you're going to look for is any point that exists on the graph for each equation in the system. So you're basically looking for any point of intersections between the two lines. So it is possible to have two point of intersections or one, and in this video we will be looking at a linear line and a circle, a line and a parabola, or if you have two linear lines. If you have a linear system, meaning two linear lines, it is possible to have no solutions, one solution, or infinite solutions. If you have no solutions, what you're going to have is two linear lines that are parallel to one another. They will have the same slope but different y-intercepts. If you have one solution, you're going to have two lines that are intersecting each other at one point that have different slopes and different y-intercept. It is possible to have the same y-intercept if they intersect on the y-axis. If you have infinite solutions, you're going to have two linear lines that overlap one another. So they would be right on top of one another, and they would have the same slope and the same y-intercept. So any point that exists for one equation would exist for the other. So let's look at an example. If you're asked to solve the following system of equations, you will first find out which type of equations you're dealing with. So in this case, when you look at the first equation, you can tell that it is a parabola because it is in the form y equals a times x subtract h squared plus k. And we know that the vertex is always h and k, so in this case, it is 4 and 2. By looking at the second equation, you can tell it is a linear line because it is in the form y equals mx plus b. So to graph the first line, you can either use mapping notation or you can use the step pattern. So I will be using the step pattern. So first I will graph the vertex, which is at 4 and 2, and then use the step pattern. So go over 1, up 1, over 2, up 4, over 3, and up 9. And then I will just connect the dots. So to graph the line, I'll first plot the y-intercept, which is b, in this case 2, and then use the slope, which is always rise over run, and in this case it is 2 over 1. So you rise 2, go over 1 from the y-intercept, and you continue doing this across the graph. And you would also do it on the back side, so you would go to the left 1 and then down 2. And then you can connect the dots to see the line. And then you can see that the two equations intercept at 2 and 6. So that would be that point right here. So the point of intersection would be 2 and 6. But before writing your therefore statement, you can do a double check. So to do the double check, you will put the left side of the equation on one side and the right side on the other. So in this case, for the parabola, the left side would be y, and then we have the equal sign, and then we had x subtract 4 squared plus 2. So then you sub in your point of intersection that you found, and that is always in the form x and y, and then you sub in those points. So for y we had 6, so we put 6 on this side, and for x we had 2. So on this side we would have to sub it in, so it would be 2 subtract 4 squared plus 2. 2 subtract 4 gives you negative 2 squared plus 2. Negative 2 squared will give you positive 4 plus 2, which will give you 6. So therefore the left side and the right side are equal. Then you would do the same thing for your second equation, which in this case was y on the left side, and then on the right side we had 2x plus 2. So you use the same point, you sub in 6 for y, and then you sub in the x value, so that would be 2 times 2 plus 2. 2 times 2 will give you 4 plus 2, which will give you 6. So therefore the left side equals the right side. And now that we found that the left side equals the right side for both the equations, we can write our therefore statement. So therefore, the point of intersection for this system is 2 and 6. So then we're done solving this question. Okay, so now let's go over example number 2. If you were asked to solve this system by graphing, we'd first look at which type of equations that you're dealing with. So when you look at the first equation, you can tell that it is a circle because it's in the form x squared plus y squared equals r squared. Then you look at the second equation and you know it's a line because it's in the form y equals mx plus b. So to graph the circle, you would first find the center of the circle. So you just take out the numbers in the brackets. So for the x value, you would take out -2. And when you take out a number out of the brackets, it becomes the opposite. So it becomes +2. You take out the -3 and it becomes +3. So you can plot that point onto your graph, knowing that it is the center of your circle. Then to find the points around the circle, you would just find the radius. Because we know that the equation is in the form x squared plus y squared equals r squared, you would find the square root of 9. Which in this case is 3, and then you would plot 3, so you would go up 3 from the center, to the right 3 from the center, down 3, and left 3. And then from there you can just connect your points, giving you your circle. Then you would graph your second equation, so you would plot the y-intercept, which is -3, and then use a slope, so it's 1/1, so you can just make the points across. And then you find that it intercepts right about there, so you just connect your line. And then you know that the point of intersection would be 4 and 1. And we didn't do this for the first example, that was a mistake, but you should. You should always label the lines. So for the circle, you would write x subtract 2 squared plus y subtract 3 squared equals 9, and for the line you would just write y equals x minus 3. And then to double check your work, you would do the left side right side check and find that if the left side equals the right side, when you sub in the point of intersection into both equations, then you can state therefore the point of intersection for this system is 4 and 1. So now let's just recap. So if you have a linear quadratic and a linear circle, there are 3 different possibilities. You could have no solutions, which would look something like this, and there are other possibilities. One solution, this is just a few of the examples, and then you could also have 2 solutions. You cannot have infinite solutions because one of the lines is a curve and the other one is a straight line. So they cannot be on top of one each other, meaning you cannot have infinite solutions.